Hey, today's the 1st of April. You know what that means? Eh, yes, the April Fool's is you thought we were going to do work today. Free day. We're going to eat nachos and play board games. Uh, nope, we're working. So today we are going to be using our compound interest formulas, but we're going to be solving for the other variables. So we'll be solving, you've been solving for A, assuming you got that assignment done. You just kept solving for A. How much money will I have? How much money will I have? So on and so forth. So we're going to solve for P, R, and T. We will not solve for N, um, despite my extensive years and experience. Uh, Dozens of Google searches have led me to the result that there's really either no accurate way to solve for N or that the skills required to do it are outside of even my reach. So there's something cryptic, and I can do more research. You can as well, but solving for N is oddly difficult. So we're going to avoid that. So we'll be solving for the starting value. We'll be solving for like what interest rate would be necessary to make this happen and how long would it take for something to happen. So rather than just every problem being find A, find A, find A, it's going to come at you from different perspectives. So when you get your assignment, probably later, maybe tomorrow, the first page of problems is going to be formatted like what I'm about to write down. And so rather than them being word problems, they're going to just come at you with 5 pieces of information. So A, P, R, N, and T, and one of them will be missing. Uh, so let's get started. So let's say we're doing a math problem, and we know that the final amount of an account or something is $85,000. That would be an answer yesterday, right? But today it's a given. And let's say that the principal, the starting amount, is unknown. The interest rate is 6.8%. The compounding is quarterly, and the amount of time is 30 years. The only time you're going to see less than that is when we do continuous compounding, because the continuous compounding formula has less variables, right? So, but the first 3 examples that we're going to do are going to look like this. And I'm a pretty predictable guy. So in this first example, we're solving for P, and the next example we'll solve for R, and then in the third example we'll solve for T. But let's get started. So step one is always to just write it down, write down the formula, but with the numbers that you have plugged in. So remember, the template that we're working with, I'll put it up here in the corner, is A equals P times 1 plus R over N to the power of NT. Not that you have to write that down every time, but just have it somewhere close by so that you can use it as sort of a skeletal model that you're going to now put things into. So what's the first thing I'm going to write? Say again. There you go. Good job. So where it says A, we're going to write 85,000. And you should take out, once you start calculating, take out dollar signs, right? No need for those. Take out commas if you like, right? What's the next thing I'm going to write? P, because that's the one thing that is still able to variable, right? I don't know what P is. So that one's going to stay as an unknown. And then we're going to just continue the model. Open parenthesis, 1 plus, what's going on top of the fraction? 0.068. Okay. Remember, we always move the decimal 2 places to the left. There are no exceptions to that. Regardless of like, if you think something is weird going to happen, no one's interested. 2 places. Okay. Over what? To the power of, or over 4, and then to the power of what? 1. Good job. You guys jumped right on that, right? N times T. No sense in writing 4 times 30 when I can just crank it out in my head. 4 times 30, done. Over the next couple of days, you'll come to appreciate certain problems more than others. This will be the one when the dust all settles on the next couple of days that you'll like the most. And the reason is because the attack plan here is simple. To get P by itself involves very fundamental sort of seventh grade algebra skills. And it may not look like it. I get that. But if you think about it, like if I gave you an equation like this red one, if I said 10 equals P times 2, how would you solve it? You divide by 2, right? No questions asked. We understand fundamentally how algebra works. Like we have those mechanics, sort of those instincts starting to get instilled. And we know that when it's P times whatever, it doesn't matter. We're going to divide by whatever. So this is sort of a one-stop shop problem. This, like I said, is the good warm-up-y one that becomes our simple favorite. All I have to type into my calculator for this to get P by itself is 85,000 divided by 1 plus 0.068 divided by 4 to the power of 120. Let me ask you a question before we type this in and figure out the answer. Why are these red parentheses not required? I mean, if you want to put them, you can. FYI, they're not going to hurt anything. But why don't I need them? When you put calculator parentheses in, you're bossing your calculator, you're bullying it into breaking the order of operations. You're saying, calculator, I need you to break the law. And in order to do that, I'm going to give you some parentheses and force you to do something first. Why are the red parentheses not necessary?
There's nothing for B
Mm-mm.
already. Parentheses.
Mm-mm. Let's talk about this. If I leave this just like it is, walk me through the order of operations. What's my calculator going to do first?
On the parentheses.
It's going to calculate the inside of the parentheses first. So inside of that, it's going to do the little division problem, the 0.068 divided by 4, and then it's going to add 1. And it's going to do that because we bullied it with parentheses to make it do that. But why am I not required? Because you understand, of course, that we do not want the calculator to divide 85,000 by this and then raise that to the 120th power. You get that, right? Because the exponent will go first anyways. Again, someone way smarter than me got paid probably a lot of money to program the calculator to do what it's supposed to do. And so it's going to exponentiate first anyways. If you feel uncomfortable, like you're kind of hanging it out there in the open, feel free to add a manual set of parentheses if you like. But in a case like this, they're not necessary. Okay? It's going to do what you want it to do already. So let's practice. Let's type that in and see what we get. You do need those white parentheses, though, of course, right? Without those, you're cooked, as they say. So we're going to go 85,000, hit divided by, open parenthesis, 1 plus 0.068 divided by 4, close parenthesis, to the power of 120. Before you hit enter, let's just think for a second about what kind of answers would be not stupid. Tell me ballpark. Not even being at expert level yet, what do you think the answer might be? Give me just a ballpark. How much money would I had to have invested? That was really bad grammar, I think. How much money would I have invested to get it to turn into 85 grand over 30 years at 6.8% interest? Take a stab. Okay, fine. Since you don't want to talk to me, how about this? If my calculator in a second says 120,000, what am I going to feel like? That's really hilariously dumb, right? How could I start with 120K, get interest, and then, well, how come my account balance went down, right? So you understand there's a spot in there. Do I know what it is? Absolutely not. It might be like 24K, 19.6, 30. I don't know what it is, but it's going to be somewhere in that less than 85,000 range where if we smack it with interest, it's going to billow up to 85 grand. So hit enter. That seems reasonable to me. So according to my calculator, the principal amount that we would have had to start with to get it to reach 85K under those circumstances would have been 11,000. Hopefully you got the same thing as me, $243.58. And having done yesterday's assignment, that should feel pretty vibey to you. Like that, I agree with that assessment. If you start with that much and let it do its thing for 30 years, pretty good interest rate. I like it. Okay. One down. Any questions about that one? Come to appreciate that one. It will be your favorite. All right, in our second example, we're going to solve for something else. So in our second example, we're again going to have a final amount of 34,521. We're going to know our starting amount, 15K. We're not going to know our interest rate. We are going to know that it's monthly compounding, and we're going to know that the amount of time it took is 20 years. So the phraseology of a question like this as a word problem would be something like, what interest rate would be required for an investment of $15,000 to grow to 34,521 with monthly compounding for 20 years? Okay. And again, the steps are, the first step is non-negotiable. You write it, plug all the stuff in. So what goes first?
34,521.
You bet. Second,
So
15,000. Next up is the 1 plus. What goes on top? R. We can call these pirate problems. R. What goes underneath the R? 12. And what will my power be, my exponent? 240. Okay. This is going to cause you a bit more physical discomfort. Just FYI. All right. Solving for R and solving for T are a little bit tougher. By a little bit tougher, I mean quite a bit. So let's think about basic algebraic fundamentals. What would you do first? Take a shot. Follow your instincts. That's no. If I gave you 100 equals 4 times x to the 10th, you just took a quiz over this the other day. What I just wrote is not all that different from what's on the board. Follow your instincts, your knowledge. You've acquired these skills. What would you do first? You would divide by 4. You know that your job before solving anything like this is to isolate the power. So in the same way that on a quiz that we took a few days ago, we would divide both sides by 4, the logic doesn't change here. In the same way that we would want to get this yellow jelly bean by itself, we want to get this large yellow, whatever that is, by itself. Okay. Again, it's basic algebra. It just doesn't look like it. But the basic algebra knowledge that we have tells us we need to divide both sides by 15,000. Okay. So we're going to take our calculator. This probably is not going to end well. So if we take 34,521 and we divide it by 15K, we get a decimal that's actually manageable. So this is one time when I'm just going to go ahead and write it as a decimal. I don't hate all decimals, right? So this one actually came out pretty slick. It's just exactly 2.3014. You know, hanging around with me, that if that had said 2.3014275986, then I would have, I would leave it as a fraction, right? But this one's nice, so we'll take it. And it equals this. And this is where we're going to do something that I've never asked you to do before. There's a button on your calculator that I've never asked you to use before. What do we do? You see the problem. I know you don't want to talk to me much this morning, but the problem is that the variable I'm trying to solve for is in prison. You see that. I want to do basic algebra. I want to subtract that one and multiply by 12, do all those things that I know I want to. Let me in, let me in, let me in. But I can't because they're imprisoned by a set of parentheses and a big annoying exponent. Bless you. How do we kill that exponent? You take the 240th root, right? All exponents can be canceled by their corresponding roots. You guys know squares can be killed with square roots, right? So we have to go find a button on our calculators now that will allow us to do the 240th root, which is crazy to think about. Like a square root, the human brain can handle third root, fourth root. We're getting to a point where it's like, holy buckets. So on your TI 30X, if you're borrowing one of mine today, or if you have your own, there's a button that says this. Above that, it says this. Don't hit that button. What is that symbol called, that purple symbol? That is specifically a second root. That is not going to do me any good in this case. Right above that on your calculator, again, if you're using a TI, you have a button that says this. And this is how we do any sort of exponentiation, right? That's like I can take anything to whatever power I want, right? And above that, you will see a thing. It's very, very small that says X this. That's your guy. So what you have to do is you have to plan ahead. Unless you have a nice, like modern, super modern, nice $100 calculator, usually what you have to do is you have to start by typing in the 240th and then hit that button. So like if you type 240 and then hit second up arrow, your screen will look like this. That don't be confused by that. What your calculator is telling you is that you're using the 240th root. It's not 240 times. Okay, that's just $12 calculator speak for the 240th root. Right. And we're going to take the 240th root of 2.3014. Okay. I don't know if, yeah, you see how the root sign does not grow? It's okay. The only time you would need to parenthesize would be if you're going to put more stuff in there, but we're not. We're done. Hit enter, and you get 1.00347928. You can see that that's probably not the kind of number that we want to tote around for the rest of this problem. So let's go back like we often do, and let's preserve the integrity of this problem or this number, and let's leave it like it is. So what the problem now looks like is the 240th root of 2.3014 equals 1 plus r over 12. And the beautiful thing just happened, and it's that the captain has turned off the seatbelt sign and says, everyone, you're now free to move about the cabin. And that one, he's not bound up in jail anymore. He's like, wait a second, can I move to the other side? Yeah. And that 12's like, wait, can I get like multiplied? Yeah, go ahead. Because they're not bound up in that prison anymore. So what kind of algebra are we going to do here? What order are we going to eliminate the 1 and the 12? Who's going to go first? We're going to subtract 1 first. So our answer is going to wind up looking like this. We're going to have r equals the 240th root of 2.3014 minus 1. And then what are we going to do to get that 12 across? So we're going to hit enter right here on our calculator. Unless you used some foresight and put parentheses around that, hit enter and then hit times 12. Okay. So let me get caught up to you here. So I have in my calculator the 240th root of 2.3014. And then I'm going to subtract 1 and I'm going to hit enter. That number on my calculator screen is of absolutely no interest to me at all. And then I'm going to multiply that by 12, whatever's on my screen. And I'm going to wind up with a decimal, and I hope you did the same as well. You should have gotten 0.0417483355. Now, what were we looking for when we started this journey 10 minutes ago? What were we trying to find? The interest rate. And there it is. What would this be? 4 point, so we could say R is around 4.17%. Pretty remarkably cool mathematics that we're able to actually go back and reverse engineer that and figure out that if I had that interest rate for that many years, I could turn A into B or P into A, I guess. You would agree to step up? Once you get pretty good at it, it just kind of flows and you can kind of get good at just seeing the order that you're going to do things in. And now the last one is solving for T. So in this problem, how about I'm going to call an audible on myself. Let's do easy numbers. I'm going to change these so we don't have to deal with decimals. All right. So I'm going softball mode here. I'm going to call it down to 100,000. And for P, I'm going to knock it down to 20,000. That's nice, right? Can you see why that's good? Do you see what the writing on the wall? Maybe, maybe not. Either way. Okay. And then the interest rate, let's do 8.05%. We're going to do daily compounding. And as you know, because I said it, time is going to be the variable. So the phraseology in a question like this is how long would it take for an investment of 20,000 to become 100,000 at an interest rate of 8.05% compounded daily? That's how a question like that would come at you. Step one.
Red belt.
Did I mess up? No, that would only be if it was continuous compounding. We will use the PERT equation, but maybe not today. I have them on here, but I know I'm getting to the point where I can't expect you to. So I'm going to maybe call another audible and cut this lesson in half and give you the assignment after this problem. So we'll see. Calling lots of audibles today. Flying by the seat of my trousers. Step one. Right, start writing the stuff down, right? So A equals P times 1 plus what? What goes on the top of the fraction? What goes on the bottom? And what's going to go up in the exponent? 365t. And it's here where we kind of go, ruh-roh. But this is why we do this lesson in this unit after we do logarithmic and exponential equations, because you are now armed and dangerous with skills. And one of those skills is how do I solve an equation when the variable's hiding up in the exponent? And you know the answer to that question. Logs. We have to use logs, right? It's the only way to get them down. So before we, what? What do we do first? Divide both sides by 20K, right? So you see why I called an audible, because I don't want this to be a source of stress. So let's just take 100,000 and divide by 20,000. What do you get? That's nice. Yeah. I thought we could make this a little bit more relaxing if we just put a nice easy number there. Oh, Daddy, here comes the scary step. How am I going to do this? How am I possibly going to look up in that exponent where my t is at and say, I got you, sucker. Get down here. How do you do it? When you graduate from this school in a couple of years and you head off, probably most of you to college, you're going to probably wind up taking a math class. I'm thinking I'd really like it if a lot of this, listen, you're going to forget a lot of high school math. I'd like it if you'd remember this one. This is a really powerful trick. I taught it to you a couple weeks ago. When you want a variable that's hiding in an exponent to come down and quit being a chicken boo-boo, you apply a logarithm to both sides of the equation, and that enables you to fly your exponent down in front. Having said that, we're going to take the log of the left-hand side, which is the log of 5. And then we're going to take the log of the right-hand side, which is the log of 1 plus 0.0805 divided by 365 to the power of 365t. Now, you might be wondering right now, hey, Mr. Ahern, have you been hitting the sauce? Why did you leave that big space after the equal sign? Why did I do that? Why did I put a space right there? Okay, better question. Why did I take the log of both sides of this equation? So I could move it down. And so I'm thinking, boy, it sure would be nice if I had a little space there, right? And honestly, once you get back in your groove with exponential equations, you're going to be like, I got this. You probably wouldn't even put a space. You'd probably already be thinking a step ahead of me, and you already would have taken the 365 and the t, and you would have dropped them right down in front like you knew you were going to do anyways. That's why we take the log, so that we can do that. And t is no longer hiding from us like a little coward. Got him. And now it's all just basic algebra. That's massive. I want you to leave high school with that knowledge. Okay? I can solve any equation in the world, even the ones where the exponent tries to hide up in the exponent. If the variable tries to hide up there, I can do that too. I can use logs. That's huge. Now, how do you solve for t? We're not quite done. We're kind of done, but we're not quite done. How could I get t by himself? How would you solve for t if I said 4 equals 3 times t times 2? How would you solve for t? By what? By 6 or by 3 and 2, correct? This is just algebra 101. So I would just divide both sides by 3 and 2, like this. You agree? Then the 3's cancel and the 2's cancel and the problem's over. We're going to do the same thing on a much more 11th grade level. We're going to divide both sides of this equation by 365 times the log of 1 plus 0.0805 over 365. It's the exact same thing that I taught you back first week I met you in Algebra 1 a couple years ago. You want to solve an equation? C times, do divide. C minus, do plus, right? Which leads me then to this. What do I put in my calculator? Holy dumpster fire. Let's admire the right-hand side first. Look, this 365 cancels this 365. This big gnarly logarithm cancels this big gnarly logarithm. And look who's by himself. Mr. Happy. We're done. So what it looks like in a calculator is this. You're welcome. Follow along with me here. I'll type it in after I'm done writing this on the board. We're going to type in log of 5. And your calculator is going to give you parentheses, so make sure you close them, and you're going to hit divided by. I'm changing colors now because I want to make sure you don't miss this. You need to put your own parenthesis right now, because we're going to bully the calculator into doing the order of operations incorrectly. And inside that purple parenthesis, we're going to put in 365 times the log of. Your calculator is going to give you its own parenthesis. You're going to go 1 plus 0.0805 divided by 365. And you must now hit the old double close. And I use my colors intentionally. This white parenthesis closes the argument of the log. This purple parenthesis tells the calculator we're done denominatoring. Here it goes. I'm going log of 5 divided by manual parenthesis 365 log calculator gave me parenthesis 1 plus 0.0805 divided by 365 double close, and I got 19.92. Did you get that as well? That means it would take roughly 19.92 years at those interest rates, principal 9209967. Maybe I hit a bad number. Oh yeah, I did 0.0808. Let me go back and fix that. 19.995222217. That's better. Sorry, my friends. So I would round that to about 20 years. Okay. Yeah, so I am going to stop myself, even though there are more examples. And what I'm going to do is I'm going to hand out assignment 41, and I'm going to ask you to do a few exact specific problems. Can we agree to these terms? And then we'll just pick this up on Monday. I knew this is a bit more probably than I wanted to try to do in one day, but I thought, what is it? YOLO, right? YOLO.